Hi everyone, welcome to another video, and today we're going to discuss about max heap. In our last video we have discussed about the min heap, and max heap is no different, only the comparison direction will change. We used to check the minimum item and then we used to swap it. Now we're gonna just find the max item and we're gonna swap it to the min item and so on. So now let's discuss it on the whiteboard. Similarly, like min heap, we used to have an array. In max heap we also gonna have an array, right? And now we're gonna insert a item, maybe 5, right? Since the array is blank, 5 will be getting inserted. Now the next item we're going to insert is maybe 10. Now when 10 get inserted, let's see that 5 and 10. Now 10's position is now 0 and 1. Now our self adjustment logic will kick in. So it will check the current child index equals to 1. So parent index will be 1 minus 1 by 2, that is 0. So 0 is parent. Now it will compare is 0th index is greater than current index, right? That is no. Then we have to swap it. So it will swap the items. Now 5 will become 10 and 10 will become 5. So in next iteration, if we enter another maybe 6, now it will see 6 and 6 index of 6 is what become 1, right? And the p index will become 1 minus 1 by 2 equals to 0. Is 0th index, that is 10, is greater than 6? Yes. So it will not gonna swap. Our 6 will stay in the end of an array. So you see that with this logic, the topmost item of our array will be always the max. Just like in the min heap, the topmost item used to be minimum of all the items. In this particular case, in max heap case, I would say that the top item will always be the max item of that particular array. Now what happened when we remove one item? For example, we remove 10. Then 5 is not the max item. 5 need to become the second item, and 6 should become the first item after removing 10. In that particular case, let's take out 10. Now your parent index becomes 0. Now it will find the child. Okay, let's consider the left child and right child. Left child is become like 2 into 0 plus 1, that is 1th index. There is no right child. Right child will become 2 into 0 plus 2, but here it is not there, so we're going to consider 6. Then it will compare both the children's. If there is a RC, maybe, okay, it will compare both and see what is the maximum of those two. In the case of min heap, we used to see what is the minimum of the two. In this particular case, we're going to see what is the max of these two. And then here we'll find LC. Then we're gonna swap that. If 5 is less than 6, yes, so we're gonna swap. So 6 is gonna come here, 5 is gonna come here, and the same logic we're gonna repeat until the end of the array, until our parent index becomes goes to the length, stay within the bound of the length. The same way, while doing the heap up or adjusting the heap from the bottom, when we push something, we have to do it until the parent index remains greater than 0. and that would give us our required heap. Okay, then let's implement. So we're going to create the heap up method, and in this method our ci will be the last index. So let ci equals to this dot heap dot length -1, and then let pi equals to math dot floor, and we're gonna do here is ci -1 divided by 2. This is gonna give us our parent index, and then we're gonna do while pi greater than equals to 0. We're gonna keep doing it if this dot heap our pi is smaller than this dot heap ci, then we have to swap it. So this will become this dot heap dot pi, then this, this dot heap and ci. I'm gonna swap it, this dot heap ci, and this dot heap pi. Perfect. This will swap it, and then we have to make our ci equals to pi, and then we have to derive our pi equals to same formula, method floor ci. So this should do the trick. Anyway, now we have to call it in our head. So this dot heap up. Perfect. Now let's create a size method as well. Size that will give us return this dot heap dot length. Yeah, so we can use this method here, yeah, as well. That will do the same thing. Now we're gonna create a method to return the top will return the top of the value without mutating the heap. Return this dot heap of 0. Perfect. Now another thing is like pop. So pop will remove the top item. So let pop equals to this dot heap dot shift. Then we have to heap down the then return pop. So we have to write this method now. The same thing. We have to find the left and right child. Let pi equals to 0. We're going to start from the top. Let ci, that is left child, or I can lc, left child equals to pi into 2. Sorry, let's get pi into 2, then plus 1. let RC equals to LC plus 1, and then while pi lesser than this dot size, because it's the length, we don't have to go make it equals. So now let mi, the mean index, will be if, so let's let's write this logic here inside our while loop. Mi equals to if if this dot head heap, this dot heap li lc is greater than this dot heap rc, then we have to return greater here, lc, otherwise rc. Now we're going to do the same check. If this dot heap of pi lesser than this dot heap dot mi, then we have to swap it. So yeah, this dot heap pi, and this dot heap mi equals to this dot heap mi and this dot heap pi, parent index. So this will swap it, and then we have to update our parent index, that pi equals to mi. So this should do the trick. Now I have written the test cases, the same test case, I reused it, and I'm adding 7, then I'm adding 10, then 5, then 2. Now if we get the top, this should be a max heap. Let's rename it to max heap. Yeah, perfect. So yeah, then if we get the top should be 10, because 10 is the max item. If we pop, 10 will be popped, then the next biggest should be 7, and the side should be 3 because we removed one of those. So now let's run it. Okay, add value is we have to push it. Now what happened? Oh my god, I have to take English class. Perfect. So that's it. So that's how we're gonna construct our max heap. Nothing. If you know how to create a min heap, you're gonna create a max heap, and just we have to change or reverse the comparison logic. That's it. Everything else remains the same. So that's all about heap. Thank you so much.